Well, my name is Leszek Maciaszek, and I represent Macquarie University in Sydney and Wrocław University of Business and Economics here in Poland. And I am an honorary chair of FedCSIS', and I thought that I am coming here as an observer, but I was asked to chair your session, Lipika, and it is my great honor to be able to do that. Now, a few words about Lipika. Lipika, in my fingerprint words on my phone, okay, it does. Lipika Dey is from Tata Consultancy Services in India. She is a chief scientist at Tata Consultancy Services, and she is a fellow of Indian National Academy of Engineering. She is also a fellow of Asia Pacific Artificial Intelligence Association. She was awarded the Distinguished Scientist Award by TCS in 2012, and so on and so on. I mean, you've got some brief information, brief bio, Lipika on the conference site, but it's easy to click on. You know how we do it. Lipika Dey in Google, and she is on top of the list there. And Lipika is going to talk today about deciphering clinical narratives, augmented intelligence for decision making in health sector. So very interesting topic, very timely, in particular for older people like myself. So I will be listening very carefully, as you only do, to this presentation. Lipika, we would like to give you like 45 minutes, because as you know, at any keynote, the most interesting part is the discussion. And we have quite a few people here who would be interested to interrogate you. So if you can manage in 45 minutes, it would be great. Just after your keynote, we have another keynote. So, so the floor is yours. And, well, go ahead, please.
Thank you very much for the kind introduction. Good morning, everybody. I'm very sorry I could not manage to come there due to certain issues here regarding obtaining a visa. The line was too long. I should have started possibly 6 months back, which I didn't. I started about 3 months back, and I couldn't make it. So, yet I'm honored to be still here talking to you about the work that we are doing. I have already shared my screen. I hope you can see. I just go to the slide view mode. Is everything okay? Just let me know and I'll start.
Everything is okay. You can start.
Thank you. Yeah. Okay. So as it says, our interest is really in talking about clinical texts and what kind of decision-making pointers can be obtained from this. So overall, the way I have arranged the talk is, I'll just talk a little about clinical texts and the decision-making problems. Moving on to our first part of the work, which is about predicting length of stay in intensive care units using clinical narratives which are there in nursing notes. The second part of the talk is delving deeper from there into how can we identify patient similarity groups or cohorts from there to understand even better about patient groups, because that's the way medical fraternity usually works. And then I'll be sharing some of our learnings. I'll be sharing the learnings as we go on. So what are basically clinical narratives? Now, though we all have worked with the machine learning data sets or heart data set or diabetes data set and so on, the actual medical domain is dominated by text data. So a lot of things that are written on prescriptions or is actually written in the reports or recorded particularly by nurses while observing patients is a gold mine of information. However, most of the machine learning paradigms have not even worked very much on this data, which are actually the narratives, which are the main form of communication within healthcare. So a quick look at today what comes to us as clinical data. So of course the electronic medical records with a lot of details and structured information, that is metadata, also stored about patients. The physician and caregiver notes are a part of it, and there is also like clinical trials management. So a lot of text data is also generated by the companies who are doing clinical trials, because they have descriptions of clinical trials and then they have detailed records of everyone participating in it. The second form that is also becoming very important because of patient support groups are really the social media, where people not only get together to get community support, but even with doctors and caregivers connecting over there. There's a wealth of information for the medical practitioners who come to know about adverse drug effect and whatever other kind of issues that patients may be having. Of course, medical literature is something which has been used by the machine learning and the natural language processing communities for quite long, so I'm not going into the details of it. There's a lot of information out there which can be used and is used by the pharmaceutical companies. And then there is another area altogether which I'm not going to touch today, but is also a part of the clinical narratives, which is used by the insurance providers, particularly for assessing, for underwriting and assessing what should be the premium for patients. So this data, why is it taking such a huge proportion? It was actually estimated to be quite large even before COVID, and one can only imagine by how much all this data has gone up in a post-COVID world. And this is just an assessment by a finance management company who says that healthcare data, healthcare-related data growth, where the data is entire digital data, is greater than all other areas as such. So though we talk about media and entertainment and other kinds of things, it's actually healthcare data which is out there, a lot of it. Now, what are the challenges, however, while we are working with really clinical data, not just data from open sources, social media, or other places, or even when we are working with data that is out there for a particular purpose, say on social media for support group, but if we are trying to get information from there, first of all clinical narratives have huge privacy challenges, and therefore not a large quantity of it is available for doing research, doing in-depth research. That is what makes training and evaluation of machine learning techniques quite difficult. What you will see when I will talk about it a little is that there are evaluation issues that often come up when we do such work because of non-availability of data. And then even when these textual narratives are available, then they use doctors within the same hospital, across hospitals, across geographies. There are many non-standard terminology users. So therefore that again becomes a huge issue. That is a challenge of working with clinical data. What kind of decision support systems are we looking at in the healthcare sector? So of course, one of them is about hospital logistics management itself. That is what we are seeing a lot of it, particularly the critical care facilities, which are fewer in number, which are expensive resources. So they are interested in application of machine learning to help them with better prediction of requirement of resources, be it human resources, be it other kind of physical resources. The point where it comes very important to medical practitioners, of course, is also the expectation management for patients and family, if they can have better prediction of what would be the cost, what would be the stay, and so on. And the last one, of course, is about personalized patient care, where entire medical science is moving towards it. A lot of them are moving with genetics, but also a lot of it is trying to move with other kinds of data that are available from electronic health records, clinical narratives, how much of it can be used for personalized patient care. So these are three very broad areas in which the studies can be applied. What I will start with is really the low-hanging fruit, which is ICU length of stay prediction. The data set that I will be using, as I mentioned, there are huge challenges of working with medical data, particularly clinical narratives, because a lot of personal information can be out there. So we work with a particular data set that is Mimic3, which was made available for purposes of research by Israel Techonis Medical Center. The data was prepared with care by Laboratory for Computational Physiology of MIT, and they are the ones who made this data available. It's still quite small, but nevertheless, we still have it at least, which is about 58,976 admission records of about 46,000 patients. So some have multiple admissions. Admissions are both to ICU as well as hospital, and it has all the approvals that are necessary. The data has gone through stringent anonymization protocols so that no privacy violation is ever faced. Even, and we will talk about time-stamped data, but the times are really relative times, but not real times that are used. To work with the data itself, there is a training course that has to be completed, about actually 8 different modules that have to be completed, after which one gets to access the data, and every author of a paper working on this data will have to clear this test. So we have gone through all the rigors of accessing and working with the data. So as I already mentioned, ICU length of stay prediction, it's an important problem for hospital logistics management, and World Health Organization has also declared that length of stay in hospitals is an important performance measurement and monitoring indicator for healthcare sector itself. Of course, the cost factor is an issue, and all hospitals want that their ICUs don't lie vacant, as well as they don't want critical patients to be turned away because of non-availability of ICU. And that's why this becomes an important problem, and we see more and more hospitals who are getting interested in this work. Okay? Of course, the earlier the prediction is made, the better. So there are many flavors of this prediction problem. It could be, can you predict how many more days are left in ICU for a patient? It could be, can you predict the number of days at the beginning, or it could be at least, can you predict whether it is going to be a short stay or a long stay. So here is just, we are not the only ones. Work has started for quite some time now, and there are different groups who are working on the problem. So particularly what I show over here are the methods like standard machine learning techniques like random forest, XGBoost. These have been used. LSTMs have also been used for predicting the accuracy, predicting whether the length of stay in a hospital. And there was also one work which was our first work, and this work was almost published simultaneously, who used the discharge summaries from the electronic health records of the same data set for a subset of the patients. The discharge summaries are kind of an aggregate of all the narratives. So just when the patient is discharged, at that time there is a union of all the narratives that are given over there. So this group, they worked with that particular text data, and in this entire series, that's the only group who worked with text narratives. All the others were actually using the vital parameters, which are more numeric or categorical in nature. So what does a nursing note look like? Now, what we are working with is mostly a nursing note. Now, a nursing note is a time-stamped note, and a very detailed one, as you can see, a very noisy one too. So, there are a lot of abbreviations which any division uses, and these are no exception. So you see PT is for patient, 62 YO is year old, and so on. And now to make sense of all of this is a task by itself. It contains, now why did we, of course, electronic health record also has a record of the disease for which the patient was admitted, the drugs that were given, and so on. So certain even numbers about, what was the ICD code or something like that was also given over there for the symptoms. However, as you can see, the nursing notes actually are very detailed and time-stamped account. So this is one which was generated on the first day of admission of a patient's stay in a hospital. It has observations made by doctors about symptoms and diseases, which are also there in other columns. It has prior medical history that is also maybe there in prior history in electronic health records. However, what starts changing is it also has suggestions. So not necessarily actions which are taken, but suggestions, observations, and specifically about general conditions about a patient, like appetite, whether a patient is able to sit or not, what is the type of pain that the patient is showing, and so on. So now these things are very indicative of a patient's condition, which indicates also maybe in future why a suggested treatment may not have been taken on a particular patient, or why a path was changed for a particular patient. Often these kind of details are not there in the structured fields, but these are the details of why an action is taken, how the action changed over time, or the action decisions changed over time. A lot of such kind, or even if a medicine was given, the structure may say that medicine was changed next day. What it would not say is the patient responded very badly to the medicine. That information would only be there in the nursing notes. So that is where our intent was. We wanted to start working with the first day's nursing note that was prepared after a patient is admitted to ICU. We of course also took the vital parameters, and our task was to predict the length of stay. Now when we started looking at all the work, we saw that everyone was working by predicting not the exact length of stay, but saying whether it's short or long, We also tried doing short, medium, long, and so on, but mainly the inference is categorical. We talk to the doctors, and the doctors say oftentimes exact state is based on multiple other factors like age. So two people given exactly similar symptoms, if the person is of a higher age, may be kept for a longer time. Pregnant mothers may be kept for a longer time. Availability of the facility and sometimes patient willingness. So that's why it seems this area as such works with more categorical inferences than others. Okay, so now with the work. So here is a patient nursing notes that we can see. So our first hunch was just go embed it using all the powerful transformers that are there, and they should do the job. Unfortunately, that did not work, though we do have them. So we have to introduce a lot of those linguistic tools that were there. Some of the tools that we have built in-house, like the third yellow box that you see over here. FedCSIS is a common tool that is used for processing biomedical text. Cleaner is another tool for this. Now all these tools, including our tools, are built on neural networks themselves, deep neural networks and LSTMs, transformers, whatever. But these tools were first had to be used, and the transformer did not do a good job of just generating and embedding and sending it to a classifier. So by processing it through these tools, we are able to identify separately the disease names, the tests, the treatments, the demographics like 83-year-old female, health condition, lifestyle, etc. All of which seemed to become quite garbled if we only used the transformers. And this color coding means different tools are used for different things. We take a union of the results when it comes from the multiple tools. For drugs, we used the mimic data itself, which is there in some other field, and we detect those drugs in the taken from the record. We also detect them from the record, clinical narrative. Now the vital parameters like temperature, pressure, heart rate, which others have also used before us. We also used them, but we used them in a different way. We used a library that is available which can use these parameters in order to compute some scores which are called severity of illness scores. So these scores are like Apache 2, then SAPS-2, which is acute physiology score, sepsis score, and then acute severity of illness score. Now, it's not that we had these values always coming from the records themselves, so some were obtained as a result of the earlier step, identifying these elements from the clinical narratives and then feeding to these libraries in order to obtain the scores. So now with all of it, we were in a position to actually feed all of these to transformer architectures. So as you can see, we do feed the nursing note, but we also feed our traditional linguistic vector of the significant terms that are identified, and we also feed the severity of injury scores. So these are three different elements that are fed to the classification network. The classification network, because of the restriction of each transformer network to handle only a certain number of tokens, our nodes were longer, so we combined the transformers with an LSTM architecture, a sequentially processing architecture, and then with this very complicated combination of all the vectors and a fully connected layer on top, we have the prediction of long or short stay. We tried with two different BERT or transformer based models. So one is clinical BioBERT and one is Bluebird. Both these modules, on top of BERT, they have been fine-tuned to handle clinical language. So clinical BioBERT was specifically trained with data from Mimic3 corpus itself, and Bluebird was trained with PubMed data, so that is biomedical literature, as well as Mimic3 clinical notes. All of this into picture, we had the classification, but then we also wanted to know why a particular patient was going to short or long. And so for that, we added a layer or made the results pass through what is called the line framework for explainability, because as we know, doctors always want to know why a particular decision was taken. So we use the standard line framework, which takes the model and the decisions and then tries to analyze why a particular record is going to short or long. And some of the what it outputs is basically the words and features that it identifies from the attention layer. So what we see somewhat matches with our intuition that long ICU stays are more associated with terms like HR dropping, requiring mask, ventilation for respiratory failure, couldn't breathe, and so on. Whereas short ICU stays, and this is what is very important, and remember this is all coming from first day's nursing notes. It's saying good effect from Ativan, which means this was a medicine, it was given and the patient has immediately responded. Comfortable breathing, hemodynamically stable, and so on. Now, comfortable breathing, etc. are not terms that are recorded in any electronic health record outside the narratives. So, indeed, there are pointers that are there in the clinical notes, and when we compare our results with earlier results, we do get an improvement in our performances. We get up to F1 score of 0.81, the last one was in 70s, and we get the best one when we take Bluebird, which is trained on multitude of data, along with the SOI, severity of illness scores, as well as the linguistic vectors. So we did a lot of ablation studies in order to come up with the results. However, this is something we did new, which others had not done. Now, when we studied these results, what we saw was a lot of these ICU delays were not because of what the patient was initially admitted, but rather there were other kinds of procedures that were happening to patients who were admitted over here. So that is when we found that there were 4 of these procedures which were very commonly occurring across all kinds of patients. Remember, this is about 40,000 patient data, and they were undergoing bypass surgery, stenting, tracheotomy, cholecystectomy, when they were not actually admitted for them. So then we reformulated the problem that can we predict not only the length of stay, which is our primary goal, but also what kind of major procedure requirements a person may require, just again based on the first day's notes. Now there were two intent. So one was, of course, can we predict these procedures from the first day's notes, which no one seemed to have done. And secondly, because we could see that these procedures coming in between added to some delay in scheduling these procedures. So maybe a procedure was stated on 3rd day and was held only on 6th day, with 2 days of planning additionally required to hold that procedure. So anyway, we saw that this was again a resource scheduling problem, and so therefore we enhanced our network, earlier network, which was only doing a long or short stay, to also a multitasking network which can additionally predict what was the requirement for one of those 4 procedure. So right now we have only dealt with the 4 procedures, because beyond this, from the fifth procedure onwards, it was not so common. So this is what we did. We changed the loss functions to imbibe the loss from both these predictions and trained the classification layers along with whatever inputs we were giving. Only change we did was, earlier was only an LSTM network, we now used a bi-LSTM network, and we obtained some very interesting results. So first of all, the ICU LOS prediction again improved with the bi-LSTM, or because it was now multitask, we can't say. But what was very interesting about the multitask part is we could predict this bypass with F1 score of 0.89, stenting with 0.83, and these tracheotomy and cholecystectomy and so on. So now, when we went further into these results, looking at the recall and precision, there was something very interesting, that there were many of these elements that we were actually predicting on the first day itself, which were not there on the first day at all. And this is what we have called something like gain. So 50% of the total bypass surgeries done were not predicted by the doctors on the first day. It came somewhere on 3rd or 4th day, and our model could predict them correctly on the first day's notes. So that means there's enough information on the first day's notes, but the individual doctors who are seeing are not prescribing it. Similarly, 32% of stenting were predicted on the first day, and these 32% are only those which were not there. Ones which were there, we are not counting. The recall and precision is counted from the discharge, how many total were done. And tracheotomy, 68% of them were presided on the first day. Now, whether it was a doctor error or whether they don't prescribe it because it's painful, those things we can't say, but this is what we could see from the results that we obtained. So again, that gave us intent to dig even deeper, and we thought, let us look at actual prediction of state, and it was not so good. That's why possibly no one does it, as I mentioned, that first of all, even if our system predicts 12 and the actual day is 10 or 14, it's wrong in one sense. The other issue is possibly, and that is what we then started looking at, that two patients with very similar symptoms for major diseases, for whatever they were actually admitted, may have very different outcomes in terms of length of stay because of the other factors that they were showing. So a person, say a pregnant woman who did not have to undergo cholecystectomy, and a woman who had to undergo cholecystectomy, but both of them were admitted for pneumonia, had very different lengths of stay. So the additional symptoms along with pneumonia, which was the main case for which the person was admitted, the additional information would have actually more information about other things and overall prediction. That's what we thought. So can we sort of segregate the things? Now, individual outcomes, studying individual outcomes of patients is known as risk assessment in this area. And for risk assessment, people usually divide the entire patient groups to smaller cohorts, and that is what we then wanted to do. So, assessing individual risk usually is also a part of personalized healthcare, and for that, medical practitioners, they build their own patient cohorts such that they have individuals with common traits such as common social or health factors. Patient cohorts are very integral to the medical research. Our intent was, can we do it using machine learning, just like we were doing classification, and we can't build our own patient cohorts, we don't have the data. So because this data is made available, and in future whichever hospitals make their data available to us, can we obtain cohorts from that. And of course, in our machine learning language, we call it clustering. So here now I get into the second part of identifying cohorts within patient data. Now we studied the earlier data set completely, and we found that the categories, top 5 categories of patients in this were newborn, meaning neonatal, which are actually mother and child combined, whoever, for whichever reason they had to be brought to the ICU. And there was pneumonia as the second one. Now patient cohort has to be from same disease group, otherwise it won't make a lot of sense. So we selected pneumonia because we saw that the neonatal nursing notes require a lot of additional processing, which we are doing now. But our first study, that's what I'm presenting, which was on pneumonia, because that was about an adult patient who was admitted for pneumonia. And now I move into what we had to do. So again, our first intent was, can we just use our earlier framework for the text data, the way we were converting it, and then get an embedding and do clustering? It did not work. So now it did not work. So the embeddings that we get from the transformers did not turn out to be good for looking at clusters or building clusters. So now again we go the very traditional way of looking at linguistic variables. We now took PSI-SPACE and meta-map, which are again for disease detectors, rather than what we were using earlier. These are very specialized biomedical tools. We used negation as a concept also. We had to introduce now. These things we did not do earlier. And then we also connected with UMLS, which provides a whole lot of software and a set of readable files, thesaurus, everything to resolve the entity differences that are there that can come from multiple different sources, which were not solved to an entirety using our earlier NERs. Then what we had was union of all entities that are coming out from the nursing notes. We divided them into groups of symptoms and diseases and drugs. So this 4,000 plus unique entities are only for the symptoms and diseases. So in a sense, we are taking the clinical narratives, but we are coming up with a vector representation of it using very traditional kind of concepts like term documents. But then, as we all know, these matrices are really sparse and very high dimensional. So there were 4541 health conditions, and being so large and sparse, they do not really help in clustering. So what we did was we used these converted binary matrix for each nursing note, and then we built or used autoencoder architecture to build a smaller 500 dimensional vector that would represent the clinical notes better. So with this 500 dimensional vector now representing the clinical notes, we once again wanted to check, and now it's a smaller set only of pneumonia patients, that is length of stay prediction getting better. Once again, accuracy improves overall. Precision improved for short stay. Recall improved for long stay. But overall, when we still delve individually into each patient, like what about the remaining short stay patients, why couldn't we recognize them? This kept on plaguing us. So what we again realized is that this prediction or tasks are not really very good unless we can go deeper into understanding possibly now what are the subsets in this. And again, that is moving towards risk assessment. So we did an auto-encoding of these auto-encoding of the nursing nodes into 500-dimensional vectors, and then we applied K-means clustering algorithm. We used the silhouette score to determine the ideal number of K, and with that, now after a lot of experimentation, this is what we obtained as I'm showing you a 2D visualization of the clusters, which are okay somewhat. The green points are separated out, the purple points are here, red seems to be in two places. Of course, this is a much lower dimensional visualization of the 500-dimensional points, but nevertheless, it seems to be promising. However, we needed to understand more about each cluster. And because we wanted to know more about each cluster, so we looked at these SHAP values, which can interpret groups. SHAP value determination is based on game theory, and there are these softwares to which we fed the cluster IDs now as labels, and the points that are in a particular cluster as elements which are labeled with the cluster ID, and we gave this to the SHAP tree explainer by building a classifier using random forest. The classifier, of course, has to be quite accurate, so it was about 0.98 kind of accuracy, and that classifier, when we give to the SHAP tree explainer, what it is trying to explain is how elements from each group can be interpreted in terms of the diseases or symptoms that each group has. And this is how SHAP now gives us the outputs, which are much more interpretable. So it says cluster 0 with some color over there, I don't remember the color, now has patients primarily who are suffering from endometriosis. Now remember, these were all patients of pneumonia, that's the primary one. But this is a group of patients who, a very large number of them have endometriosis, which is swelling of cells. Then another one is actually about acquired abnormality of atrium, which is an added cardiac problem. And then there is a very big cluster of patients who are actually having influenza, who are not having a cardiac problem or unknown endometriosis kind of problem along with it. Even actually we have many more clusters, and we now generated a description of each of these clusters. So there are people, there are groups where pneumonia occurs with very high percentage of edema, which is swollen organs or accumulation of water. And we have different varieties of cardiac problem. So ventricular hypertrophy, or there are the ones that I was talking about, acquired abnormality of atrium and so on. So there are these different groups, and as you can see here, the age group is pretty high of people, but it offers us a view now about the different groups, and we did the same with the drugs. Interestingly, drug clusters and drug association to clusters were not very segregated, because the same drugs were given to all patients. We also tried to do a causal analysis of the drugs using PERT 2Y package get some values but not very interpretable, so I won't take a lot of time on this. It's like there are certain medicines like corticosteroid given to patients of cluster 6 which is reducing their state. So some things we could see, but not a lot of it. And that again is possibly because drug and clusters do not have very tight bundling. They are same drugs are given to people of all categories. Now we also did association of the initial symptoms as patients have gone into different clusters based on their initial symptoms with the ultimate outcome of deceased. So we saw that when we looked at the discharge summaries, there were 3 categories. We could brought 3 categories. One is deceased. One is patients were left but in a confused state, a mentally confused state, and they could walk only with assistance. And there was the 3rd category, which was maximum, who are in a state to walk, mentally coherent and interactive. So these are some of the key features that were marked. So now when we go back to these clusters, we have the symptoms and we look at these as proxies to risk. So what we see is cluster 7, 0 and 11, which had patients. Cluster 7 was with edema, hypotensive and left axis deviation. Cluster 0 was the one with endometriosis and diabetes, a combination. And cluster 11, primary pneumonia along with ventricular hypertrophy. These are the clusters which had very high, greater than 20%, I'm just saying, higher risk because the probability of deceased is now higher. We do some conditional probability assessments and within clusters, across clusters, and we come up with some more factors like chronic multifocal osteomyelitis as having whenever they are noticed. Now after we find these conditions, we see that they were there in the first stage notes for some, they were also there in later stages for some patients, but whatever it is, this has a very high relationship. It's a kind of bone degradation disease. And then portal vein thrombosis, again, I'm giving you the probabilities from initial stage, but it could be at any stage. Diverticulosis again is a large intestine problem, but I mean, that seems to have a very high correlation with the second category of people. So, and these symptoms were spread across clusters. So I won't say that cluster just helped us getting idea about the patient cohorts, but the conditions that we got finally seem to be spread across the clusters and are not primarily related to pneumonia, which is a very general disease. So what did we learn from this? That actual risk factors are not from the disease for which the patient is admitted, but maybe because of the associated symptoms that were noted. And what I would also like to mention is over here, from both the studies, what we are gradually zeroing in on is that while these models are learning from the majority symptoms that are present, so whether it's clustering or it is classification, the actual risk factors may be coming from the rare symptoms. Another thing that we are seeing is, for example, I was talking about chronic multifocal osteomyelitis. We did see that people with that on the first day had a very high risk of deceased. But there were also people who were detected with it on a later date, say after 7 days. Now, is it a new disease that came? I don't think so. What I think is this is something that was missed on the first day because possibly it was not in the prior history or it was not something that was thought of by the doctors to examine. So, though that if we are able to identify these symptoms which are highly correlated, which are rare in a set, but if we are able to identify now through machine learning, we may not be able to predict accurately, but would it help if these factors are known a priori to hospitals that given a condition of patients, these are additional things to be checked, and we should not wait again for 7 days to come up with this test or this information. Would that help? That would be possibly the contribution of the machine learning community. So to conclude, I have talked about the predictive power and insight providing power of nursing notes. Work that we are currently doing is also applying similar modeling, same kind of modeling of symptoms and drugs to the mid-stage records and somehow model the tracking or progression of symptoms. From there, what are the new symptoms, new deadly symptoms, and whether these symptoms were at the onset or not, when are they coming exactly, and is that what is changing the course of the disease or the duration? And that is really the reason why exact length of stay prediction is not so correct. Parts of it we did have from the procedures, we are looking at more of it over here. Reconstruction of recovery pathways with probabilities seems to be one of the ways that we are working on right now. Does it give us a risk assessment framework is what we are seeing. And we have only used the physiological parameters and the clinical narratives. What we would also like to do is use maybe, because we are working with pneumonia, the images, the radiology reports, etc. That is something we are working towards now. So these are my colleagues and co-authors in all the papers that I have talked about. And thank you very much for giving me this opportunity to share.
Thank you very much. Thank you for a very interesting talk, and we have a few minutes to ask questions. So first of all, I would ask people in the audience perhaps to ask questions. We have another microphone. I have one microphone here, so is anybody here willing to ask? Otherwise, you will make me ask questions.
Hello. Thank you for wonderful talk.
Hi.
So, actually, my question is not the scope of your work, but I want to understand the, so for example, the percentage of electronic records versus handwritten physicians' prescriptions. So, for example, a country like India, so most of the physicians prescribe with handwritten, which is next to impossible to understand. Like so how to deal? Are there any works which can handle this to convert to electronic records? And the second question is, how is it's a medical? It's very sensitive to the data. So how you can handle the genuinity of data? For example, the length of the stay is motivated by some corporate financial. The genuinity of doctors' prescription. So the stay, for example, the length of the stay for a patient. So how you can handle the inaccurate data? Thank you.
Yeah, thank you. Very good question. But the first one is really a problem to read handwritten documents. So naturally, that would need OCR and conversion into digital form before it can work. So people who work on document image recognition would be able to talk about it better. I'm not an expert in the image processing field. Now coming to the second one, indeed. So length of stay prediction, that is the whole endeavor, that while the problem is solved from a resource management perspective, why people want to dig deeper and deeper and understand every individual patient as a collection of the symptoms is to be able to predict individual risks more accurately. And in fact, that is what our aim is also to go. Otherwise, just with classification accuracy, defining a problem in some way, we can improve the accuracy. But what we really need to do is understand every symptom and its contribution towards the outcome and come up with models to be able to assess every individual patient. In fact, no two individuals come with exactly the same set of symptoms. So the whole point of this is, if I can have if I can peek into each symptom and its contribution towards the outcomes, as well as the combination's contribution to the outcome, we should be able to come up with better models. That is really the aim.
Thank you. Are you happy with Lipika's answer? You are, okay. More questions, please.
I have the microphone for the second question. So, in your very interesting presentation, you mentioned in the beginning that when working with medical data, privacy of the data is of a big concern. So my question is how the privacy-related issues influenced your research, and how did you tackle eventual resultant problems?
Sorry, how did we overcome that problem?
If you encountered any problems during your research related to the privacy of the data privacy issues.
Okay. No, so see, that is the point, that we have not worked, or even when I work with a hospital's data, I cannot publish it, I cannot share it in a forum like this. That is why we only share the results from the data that is available for this kind of work. So I showed Mimic 3 data has all these, and it has been, all the privacy issues have been taken care of. So they were anonymized, the dates were obfuscated, the times were obfuscated, and so there's no way that any privacy issues can be violated. On top of that, during data collection also, approval of the patients and the patients' families are taken, and there are certain medical data sets which are collected for the purpose where patients do give their consent, like for some clinical trial data and all that, where they do give the consent simply so that they will be benefited by the research. As researchers, we should just make sure that whichever data we are working with, we are following the strictest standards of ensuring that, so as I mentioned, we have to go through all that ethical courses in order to ensure that we are not violating it. Even before, showing this diagram of nursing notes, we took permission from the authorities that can I show 1 or 2 nursing notes in a talk. So that is permitted. I cannot share the data.
Okay. Well, the time is up, unfortunately. I'm particularly sorry for myself that I cannot ask my question anymore, and you will not be here at lunch to ask you my own question. But you have a second keynote coming. So Lipika, thank you very much. It was really very interesting to all of us. And next time we hope you come in person.
Thank you.
Please join me.